finish up taking derivatives today. So I mentioned last time that live curves are implicitly defined. Right, so circle, for instance. But we are still interested in slope. Which means we still need a way to find dy dx. This is where implicit differentiation comes in. So take the derivative of both sides. Keep in mind that y is a function of x, so you have to use chain rule. Then essentially what we're doing is we're solving for y prime. Right? So you want all your dy dx terms on the left, all your non-dy dx terms on the right. Factor out the dy dx, and then divide. With implicit, we can use a technique known as logarithmic differentiation. All we do is take y equals h of x, write that as log of y equals log of h of x, and then implicitly differentiate. So again, it's breaking it down a lot. And at the end, you'll get y times something, replace y with h of x. This is what's going to allow us to differentiate functions in the form f of x to the g of x. And a function to a function. And here are the 6 inverse trigonometric derivatives. There are 2 ways to go about deriving these. The first way is via the method of section 3.7, which is inverse functions, which is what your project's on. The second way, which is why I cover it with implicit, is using implicit differentiation. Right? Y equals inverse sine of x is the same as x equaling sine of y. And then just use implicit differentiation from there to find y prime. Let's do this first. Find slope. X squared plus y squared equals 25 at the point 3,4. Remember, the first thing we want, the first thing we need is we need to find dy dx. First step, differentiate both sides. Derivative of x squared.
2x.
Y squared is a power function.
2y divided against.
So it's 2y,
Times
and then chain rule. And derivative of 25. Nice and easy, 0. Now it's algebra. Solve for dy dx. Their slope. Negative x over 3. Slope is negative 3/4.
So like you picked 3/4, which happened to be on the graph, but if you pick points off the graph, that still gives a slope. So like, is there any meaning of the slope of points off the graph?
Well, it wouldn't fit into this equation because the point's not even on the circle, so it wouldn't work.
You can still plug it in and get an answer.
Right, but the dy dx is meaningless
Okay.
in this formula
Okay.
because
so
it's only 4x squared plus y squared, which is 25.
okay.
It's not asking for a tangent line, right? And I will not be writing out that entire thing again. xy, what kind of function is that? Product. What's product will say?
Derivative of first times second
What is the derivative of the first?
1
Keep going.
plus derivative of the second times the first. So it would be x dy, no?
Not just dy,
dy dx.
which I'm going to write as y prime in this case. Specifically because that's what they gave in the question. Y squared, what kind of function?
2 power.
Oh, look, we actually already saw that, right? Ooh. You're not going to get this one. What's the derivative of 6? Ooh. So difficult. Solve for y prime. So we need y prime on one side, everything else on the other. And factor out a y prime. And divide by that x plus 2y. We'll get to that.
Can you go back?
Can I? I can.
Really read.
Yeah, I'm back. You never specify for how long.
No, it's fine, I got it.
Actually, what I should have done is I should have gone like this and say we can specify how far back. What kind of function do we have first? What does the E rule say?
Write down marks about one.
That's power rule. What is the natural exponential rule?
Bring down the
Like
tree.
take the natural log of the size.
Bring it down and take the general.
What do you mean bring it down?
Take x, bring x, y down and take the general down.
You're definitely going to take chain rule. I agree with that.
You multiply e to the xy by the derivative of the power.
U prime e to the u. So derivative of the power times the original. Yeah.
Okay.
What's the exponent? You said it was what?
Xy.
Don't need to reinvent the wheel. We just did the derivative of xy. But what kind of function would it be? Power, or not power, sorry, product, so you use product rule. But we already did it, right? So it's y plus xy prime. What's the derivative of x? What's the derivative of y? Now solve for y prime. First thing you have to do is what? Distribute that e to the xy through, right? And we're not in algebra, right? So I think you can handle moving multiple things at once. Okay, you want to get all of your y prime terms on one side, everything else on the other. Oh, this is going to bother me. And then divide. Why do I hate that?
Can you cancel out e to the x? You would do subtraction?
Hmm?
Subtraction, yes. I don't remember why.
I guess I'm the only one who this irritates. It's not symmetric. 1 minus y e to the xy versus e to the xy minus 1.
You make it symmetric. you
That
get the
irritates
minus
me.
sign in front.
Yeah, but unfortunately, make it symmetric. That's be negative out front. I also hate negatives. So this problem is just a giant double barrel middle figure to me. Now I have to decide which do I hate more.
There's some symmetry.
Unsymmetry or negatives, and I have to say I hate the fact it's not symmetric way more. Slightly happy with that.
Went from an art piece to a math problem.
Hmm?
Went from an art piece to a math problem. I liked it better before.
You're not a math major, right? That's why I like it more. Math and physics love symmetry.
Symmetry loves.
If things aren't symmetric, we're not happy. I think the ancient Greeks were the same way. I think everything had to be symmetric with them. What kind of function do we have?
You know, chain.
What is the tangent rule?
Secant squared. Of x y.
I'm trying to memorize it, and I know it's not.
Oh, is it? Secant squared.
Tangent u, u prime secant squared of u. Oh, it's x times y again. And the derivative of x. Solve for y prime. Distribute first, right? Move y secant squared over, and then divide by what? X secant squared? Not like that. Simplify.
to 1, it would be
Why does that one make it hard?
That's
minus.
Multiply numerator denominator by cosine squared. Secant squared is 1 over cosine, right? That looks simpler. There's only one trig function instead of 2. And we've technically got rid of the compound fraction.
On the midterm, are we going to have to simplify things to simplify?
I should say, I guess that depends on my mood. Depends on my mood when I'm grading it. Good thing the Phillies have already been eliminated.
Sweet beer coolers. For free.
There's no point. 30 seconds after you're done, the kids will mess it up anyway. So I've just given up trying to have a clean house. Those two kids are like the law of entropy on steroids. Simplification depends. If it's an obvious simplification, you should make it.
Was that obvious?
To me, yes. When I say obvious, I mean something like 3 over 6. That's clearly 1/2. Now you get something like square root of 9. You better write that as 3. If you have obvious compound fractions, yes, they can be simplified.
You said everything up to today is on the midterm? Alright.
Or if the problem says fully simplify, then you will have to fully simplify.
Acceleration of circles.
Why not take second derivative implicitly? Well, good news. Already found y prime. That was example 1. Y double prime. What is the definition of y double prime?
the derivative of y prime.
Just d dx of y prime, right? But y prime was negative x over y, wasn't it? What kind of function is that? What's the quotient rule say?
Low D high over high D low for low square. Thank you so much for telling me that. It's switching those up so much.
Uh-oh, now my eraser's not working. Y, there you go. What is d high?
1.
Yay! What's d low
Y prime.
over? Oh, why would I do that? Oh, that wasn't too bad. What's y prime?
Negative x over x over y.
Which means you think you're allowed to keep y prime in it? Nope. That's where it can get to be a pain in the butt. Like, for instance, if that's your y prime, because now you have to replace y prime with that and then simplify. This one is pretty easy. How do we clear out compound fraction? Hmm?
Keep, change, what?
That, in this case, no, because that's going to give you the same thing. That's if you have, that would be the case where if you have 1 over, or a non-fraction over a fraction, then you would do that. But more generally speaking, if you have a compound fraction, there's one method that always works.
Multiply by the common denominator.
Multiply what by the common denominator?
Everything.
Multiply by y over y in this case, right?
Oh yeah, because you got to multiply by 1. It's funny because it looks like you could divide by y, but divide by y twice. Or more.
That's what you get, right? You happy with that?
Are you?
I'm asking you, are you happy with that?
Yeah, it's been a pretty good day.
I can still be simplified.
Negative x squared over 1.
Well, then you have 1 over y plus x squared over y cubed.
Oh, you put 25 on the top?
Isn't x squared plus y squared 25? That's what we simplified.
Y is 4.
Goes back, okay.
Wait, are we finding it to the point yet, or are we? Because y is 4.
Oh, yeah, I need to batter it at 3, 4, don't mind.
I need to simplify it, which is the
What's 4 cubed?
64.
And that can't be simplified.
Oh, it's the log thing. Oh, yeah.
Okay, now see, this is what was throwing me off. Okay. You don't actually belong there. Yes, you do. I'm missing one. How am I missing one?
You have a dog?
How am I missing one? Unacceptable. x is going to be different. You know that one's waiting in the wings now. It's hiding under your bed, but you know it's there. Right, so differentiate x squared plus 1 to the x. Well, it's not exponential. It's not a power either.
Should we log it?
Take the log of both sides. But laws of logarithms. What is the natural log rule? Derivative of log u is what?
It's like the reciprocal, right?
What do you mean reciprocal?
It's like 1 over u.
U prime divided by U.
Oh my gosh, it's the general versions again.
Y prime over y equals, now what's on the right-hand side? Kind of functions on the right-hand side. Product. That'd be the derivative, right? Multiply both sides by y. But what's y? What was y?
X squared plus 1, everything to the power of x.
And there's your derivative.
Shouldn't you keep it in the same form? So you raise the ln to the power? Oh, wait.
Then you have a power to a power. Right, so it's going to be ln of x squared plus 1 raised to the x squared plus 1 raised to the x. So generally, we just keep it like this. Because this matches more like the exponential rule, which says it's the function times something. Right? There's the original function times what you could think was kind of like quote unquote chain rule, right? So we'll generally leave it in that form.
How do you?
Soon we'll get to find the limit of functions like that. Something like, what is that limit as x goes to infinity or something? You know the definition of E, right?
As x goes to infinity, this would diverge to infinity as well. Infinity to the infinity, that times infinity plus 2, which is just infinity again.
This one might go to infinity. I have to do the work to verify it.
The only thing that converges is that rational function term.
Where are you? There you are. That's the definition of E. That's why E is called transcendental. Pi actually has a cool definition too. Allows integrals. It has several definitions actually. I had a shirt that had lots of them. Unfortunately, I had that shirt for years, so it's got lots of holes in it. I just can't bring myself to throw it out, so it's still in my closet somewhere. Anyway, let's look at this nightmarish beast. This is the stuff of nightmares. So you look at that. What kind of function is it?
Hell. I mean quotient.
It's a quotient, right? So you have to use quotient rule. Low, D high, O, but what kind of function is the numerator? Product. Okay, so product rule. Oh, but each of those is what? General power. Then minus high, D low. Oh, but that's also general power. All over low squared.
Oh hey, the square root cancels out. It's actually nice and neat.
Yeah, except now you have to simplify. It's actually not too terrible to use quotient rule on this one.
What would terrible look like?
Replace those with traits.
Don't.
Well, let's just say we'll make like tangent of that first function, cosecant of the second function, and cotangent of third.
Oh my gosh, it's math gore.
Now go, have fun.
Fun is a strong word.
Let's make it even more interesting. Let's say each of those trig functions being raised to a power.
Do you like pain?
Would that be true?
The logs minus each other. So log of high minus log of low.
And having
Oh, that's so much better. Now differentiate the right-hand side. Multiply by y. I'm also replacing y. Through the power of technology. Simplify it.
What do you think?
Not cute. So common denominator is going to be the product of all those denominators, right? Now every term's going to have that same denominator, so can't I just factor it out? So that's where you get those simplifications: fourth power, second power, and 3/2. Oh, this is where it's going to get fun though. Because now you have to expand out x plus 2 times x squared plus 1. Oh, that's okay. I think I'm going to cheat just a tiny bit. Menu. I think it's algebra. Fraction tools. Get numerator. What was it? It was 5 over x minus 1
Yeah.
plus 3 over x plus 2 minus x over x squared plus 1. Now I don't have to worry about doing it in my head. That's what it expands out to, obviously. And if you really wanted to, you could go even further. I think I'm happy with that. I'll let you do quotient rule and verify that you get the exact same thing. Because you're going to have to do a lot of algebra to get to that. They should have put the question like that on the midterm and said, you cannot use logarithmic. You have to use quotient. Okay. Function raised to a function, so clearly logarithmic. Now I need that derivative, which is a product. What is the derivative of sine? What is the derivative of log of x?
1 over x.
And there's our derivative. Yeah, I'll leave it. Do I want to? Oh dear. I'm going to come into it. No. Yes. I could also factor out 1 over x. And then it'd be x log of cosine x, which is just log of x to the x cosine x. Same base, you subtract the powers, right? So x sine of x over x would just be x to the sine of x minus 1. So you could write it that way as well. The inverse trig functions. Oh, they don't give me the general rules. That's sad. That's the inverse sine of u. What are we taking the inverse sine of?
3x minus 1.
What is its derivative?
3.
What's 3x minus 1 expanded out? Or 3x minus 1 squared expanded out?
9x squared minus 6 plus 1. It's minus 6x plus 1. I'm sorry.
1 minus 1 is 0. That's nice. So you get too bad factoring out of I could factor out of 9. But that was leaving with 2/3 x under the square root. I'd rather not have that. So I'd say, yeah, that looks good. There's my derivative. I'm happy with that. That's the general rule for inverse tangent. What are we taking the inverse tangent of?
X squared,
What is its derivative?
2x.
What's x squared squared?
2y.
Hyper cube.
There's our derivative. Here's the cool thing about the cofunctions. The derivative of the inverse cofunction is negative derivative of the inverse function. Right, so cotangent and tangent go together, secant and cosecant go together, sine and cosine go together. Negative. What is u prime?
y.
Square root of 1 minus, what's u squared?
25x squared.
And there's the derivative. Oh, what kind of function is that? Right, derivative of x is just 1. What is the derivative of inverse tangent x?
One over 1 plus x squared.
There's your derivative. Of course, they have to have a quotient in there. Why not? What is the derivative of inverse sine?
One over the square root of 1 minus x squared.
How do you
That would be quotient rule, right? Now simplify. That would be the derivative. Or you could pull that x squared into the square root by squaring it first. Either one. Of course, keep in mind that they are not the same thing. But they are. I think the book uses, does it do? No, it doesn't. Good. The book does use the inverse notation. Another notation for the inverse trig functions are the arc functions. They're the exact same thing. Yeah, I don't use the arc. I don't like it. I prefer the inverse better. Ah, good. Secant. Inverse secant. That is the inverse secant rule. What are we taking the inverse secant of? What is its derivative? Now we have to simplify it. Nothing I can do with that absolute value. You want 4x squared plus 4x plus 2? No. 1 minus 1 is 0.
You can take down 4.
And then you can factor out a square root of 4, right? Which is just 2. So there's our derivative. What is the derivative of inverse sine 2x?
Two x over the square root of 1 minus 4 squared.
Close.
Oh wait, no, 2 of them, I'm sorry. It's been a long day.
Divide that at 1/2. What do you get?
2 over 0.
Which is what?
Positive infinity.
Is it? Is 2 over 0 always positive infinity?
No.
In this case, it is. because of the square root.
Oh yeah, it's 0 from the positive side, that's why.
It technically is undefined, but that tends to infinity. Right, so again, typically you would write this, even though that statement is nonsensical, that is an implied limit.
If you graph it, is that at just the very edge of its domain?
Yes.
Huh.
Yes, the domain's minus 1 to 1.
Hmm.
Right, not 1/2, that's the very edge. So when I say domain, I mean the domain of just inverse sine of x, not 2x. Right, so what you input can only be minus 1 to 1. So you're right at the edge.
It's kind of funny, if you're like on the very edge, fly off into infinity.
Well, it's a vertical tangent line at that point, then, wouldn't it be?
Oh yes, the derivative.
That's why.
Okay, I thought, sorry, I was thinking about just function itself.
Good.
Great.
That's implicit differentiation of inverse trig functions. So that means you should probably, on that reference sheet, write out all the rules for differentiation. Right, because there's a lot of them. You may not need the constant rule, unless you really don't have faith in yourself. You remember that the derivative of a constant is 0. In which case, then you may want to write it down. Then you have the power rule, sum rule, constant multiple rule, product rule, quotient rule, chain rule, exponential rule, logarithmic rule, the trig rules, and the inverse trig rules.
What about limits?
Oh, I'm ignoring limits right now. I'm just saying those are just that's just differentiation. Then you have to remember how to do limits.
What is the format of limit term going to be like?
What do you mean?
Like, what is it going to be? Mostly fill in the blank, or mostly?
Well, it's in class,
Yeah.
which means it's on paper.
Yeah.
So what do you think?
Well, I guess I'm just trying to see if there's any multiple choice. Some
Do you really think I
in
can do
there.
multiple choice on paper exam?
I could be optimistic.
Yeah.
Yeah. If the answer's no, that's okay.
Like,
Let me give you a little secret of life.
Mm-hmm.
If you always expect the worst, you're never disappointed.
That's how I feel right now.
You always expect the worst, and you're going to be sad no matter what because you're too ready.
No, that's not true. If you always expect the worst, then you're never disappointed, and you can only be elated. Like when I proposed to my wife, I was expecting no. So when she said yes, it made me feel even better.
I tried that mindset.
Whereas if I was expecting yes, and she says yes, I was, well, whatever, I was expecting no. And then she said no, I'd be devastated. Maybe.
I expect the worst. The earth blows up, but good job.
Oh, that's not the worst. The worst would be getting hit by a gamma ray burst.
No, that would be pretty quick.
So it's blown up.
Well, it goes in slow motion while we're in sunglasses.
But a gamma ray burst, that is actually the worst because then there's literally nothing left.
Dang.
At least with an explosion, there's pieces left.
The fact that it can just happen in 3, 2.
Gamma ray burst just shreds everything at the atomic level, so even the atoms aren't there.
There's just death lasers.
It's literally just disintegration, complete disintegration at the atomic level.
These just exist. It's
I guess the
not
second
there.
worst would be a black hole comes up and swallows us up.
Thanks. I'm gonna get spaghetti.
Have fun, you might feel it. Good news is you won't feel your atoms being ripped apart. But you may start to feel yourself get ripped apart. No, and if you don't realize it, the universe has so many ways to kill us.
And yet we're still alive.
We're only alive because the universe tolerates us.
What if we be really annoying to the universe?
Then it's no longer going to tolerate us and we're dead. And there's not a damn thing we can do about it.
Dang.
The universe just wakes up and decides, you know what, I'm going to kill off humanity, not a damn thing we can do. I guess it's also fair to say if an alien race decided they wanted to kill us off, there's not a damn thing we could do.
But it's like really dumb. It's like a bunch of bacteria. It's like, we're gonna kill you.
Then that wouldn't be an alien race.
What if they're like squirrels? Like a squirrel.
That's not an alien race.
They're like alien squirrels, like space
Then
squirrels.
there's not a damn thing we can do about it. Because the very fact that they get to us to kill us means they're so far advanced from us.
That's actually true. What if they're dumb and they just
No, then they wouldn't be able to get to us. It's not like the movies at all. It's not this epic
I don't
David
like that.
versus Goliath battle. It's Godzilla versus Bambi, and we're Bambi. Because they'd at least have to be a stage 2 civilization to get to us. We're stage 0. Yeah, stage 1 harnesses the power of planets.
Stage 0.7.
Stage 2 harnesses the power of stars, and stage 3 harnesses the power of galaxies. We're stage 0. We can't even control our own weather.
We're predicted.
So, alien race would have to be at least stage 2 to reach us. Possibly stage 3. So they can just unleash the entire energy of the galaxy on us. And there's not a damn thing we can do about it.
Are we just like chatting as friends now, or are we supposed to be doing something?
No, I'm just letting you know that you should probably count your lessons.
Because
the universe wants you dead, you're dead. Midterm is next class, which is exciting. So we'll be in person, obviously. Make sure to bring a pencil or black ink pen. Pencil preferable,
And a calculator is allowed, I'm presuming,
I
right?
guess.
Okay.
Do we have a class up for this one?
It's just the midterm on Thursday.
I know many questions.
It's less than 10. Or I'm sorry, not less than 10, no more than 10. 100 minutes, I usually about 10 minutes a question. But that's not to say there's not multiple parts to each question.
That sounds like a whole class. Multiple choice.
I think you'll be fine. Don't panic about the test, don't panic about the exam. Because it just means that you're going to do terrible.